Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well today and you are ready for the show because we have the one, the only Mr. Ralph Bond. He'll be joining us here to talk all about 4 amazing stories that you definitely want to hear about. But before we get started, everyone, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, podcasts, archives, contests, giveaways, social media links, all that and more. Go ahead and, just find everything there. Really simple. And of course, we'll also have a link to Ralph's site. So if you want to have a more Ralph central focused experience, hey, Ralph also provides that because not only is he the science and technology trends correspondent for Computer America, he's also the tech insider for the Mark Mason Show over at KEX Portland, Oregon. So you may have heard him there as well. Yes, it's the same Ralph Bond. There's only so many of them, and we are lucky enough to, count him as one of our correspondents. So with that being said, everyone, let's go ahead, bring him on, get started, and we'll have a fun show today. So everyone, once again, he is our science and technology trend correspondent, joins us every Friday of the month, except for the next 2 Fridays, and we'll talk more about that, later at the end of the program. But every Friday, he joins us to talk about different stories. Ralph, welcome back on to Computer America. How you doing?
Hey, great to be back, Ben. And today we'll kick things off with an absolutely jaw-dropping, remarkable example of civil engineering. I can't wait to tell you all about it. It's just amazing.
All these are going to be really, really cool. And I think we'll go ahead and start with the obvious, which is, what is your mission when you come on the show here, Ralph?
Right. For first-time viewers, listeners, I'll give you a background on what I do. I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets. And I look for stories that don't usually capture mainstream attention in the press because, of course, the news cycle is so heavy. For example, this week with the Hurricane Ian, there's so little time for mainstream press to be able to talk about some of these stories. And sometimes the stories I get are kind of quirky and out there and kind of wild and wacky, but it's a big mix. And I'm always on the lookout for news that gives a glimpse into where we're headed with robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, all over the map. And what I do with each news item, with Ben's help also, is present the essential points in a really, I hope, digestible form. And I stress to our audience, please come out to computeramerica.com. Get today's show notes. It'll have links, images, and so forth, and these highlight points we're going to go through. So if you want to dig deeper, you can with those links, and it's really great. And one more thing I want to stress, that I don't compose this. I'm not originating this material. I'm an aggregator. I'm reflecting back stories. We always give credit to the sources. So with that said, hey, we're ready for a really fun day.
Absolutely. And we even have a bonus story because one just came out a couple days ago. And, it usually does take Ralph, the week before to kind of pick up on stories and things like that. So I'm going to go ahead and throw in one more at the end that is right up our alley. And we'll do that one really quick. But everyone, let's once again, the show notes will be up on the website by the time that you hear the podcast here. So Ralph, story number 1.
Yes, story number 1 just blows my mind. Denmark and Germany are building an amazing undersea rail and car tunnel, and tunnel in kind of quote marks, because I'll explain how it's a little different than the kind of tunnel you might be thinking of. Pick this story up first at CNN, got wide coverage in many other outlets as well. And friends, run, don't walk to the show notes, and particularly look at the second video that I cite in the show notes. Absolutely amazing. But here we go. Now under construction and scheduled to open in 2029 is what will be the world's longest immersed car and rail tunnel spanning the Baltic Sea between northern Germany and Denmark's Lolland Island.
Wow.
And folks, the key word here, Ben, is immersed. And let me explain. Unlike the famous channel dug under the bottom of the English Channel, so that's, going under the surface of the bottom of the ocean there, drilling away for, mile after mile. So unlike that, this new tunnel system called the Fehmarnbelt, that's Fehmarnbelt is the first word, Fehmarnbelt fixed link. It will be comprised of 89 massive cast concrete sections measuring 217 meters long. That's about 712 feet. And it will be fabricated on land and then towed sequentially, module after module, out to sea. And each segment weighs more than 73,000 tons. That's TONNES, I'll explain, and is cast incrementally over a skeleton of reinforcing steel in large casting molds. The scale of this project is just melts my mind. So a ton, a TONN, also known as a metric ton, is a unit of measurement equal to 1,000 kilograms, and a ton, TONN again, is larger than a U.S. ton. So just to put this into perspective, so the message here, each one of these modules is very heavy. It's just massive. So when a segment is completed on land, and they're creating a whole kind of harbor, dock, and dry dock and so forth system in a factory, if you will, right on the land. And then they're going to ship these things out, tow them out to sea. But when a segment is completed on land and ready to be towed out to sea, each end of the segment will be sealed with a bulkhead. Oh, by the way, the video you're showing right now is showing what I'm speaking of. Yeah. Each section will then be immersed about 130 feet below the surface to rest on a 12-meter deep trench dredged on the seabed and then connected together. So once again, we're not talking about digging under. We're talking about laying on top via this trench. And it's a brilliant scheme that dramatically cuts the cost and time as opposed to digging or drilling under the seafloor as they did with the channel. The trench, by the way, is dug deep enough. I thought this was really clever. The trench is dug deep enough so that the top of the tunnel segment matches the level of the natural seabed. And there's a reason for this. The plan calls for stone to be coated or deposited over the top of the final tunnel. And over time, they predict sand and other things will naturally cover the stones to recreate a natural sea floor and return of sea plants, etc. So basically, after a few years, you would not know the tunnel was just below the sea floor. And I think that's good from an environmental point of view as well. And this amazing project, again called the Fehmarnbelt Fixed Link, will be a 11.1 miles long tunnel. We'll have 2 double-lane car motorways and 2 electrified rail tracks separated by a service passageway, making it the longest combined road and rail tunnel in the world. So it does have a world's biggest whatever on its own right, just as a combined road and rail tunnel.
Right.
After more than a decade of planning, construction started on the tunnel in 2020. And in the months since, a temporary harbor and construction facility has been completed on the Danish side of the project. And the construction site is now Europe's largest civil engineering facility and the world's largest concrete production facility. This project has so many world's biggest, whatever. It's just great. And the tunnel has a construction budget of about 7 billion euros, which actually I'm surprised is not more. Today, if you were to try to make this passage, you'd do it by ferry. No surprise. It would take 45 minutes by ferry to do the job, to take a few cars across back and forth over and over again.
Right.
But when the tunnel is opened, it will take just 7 minutes by train and 10 minutes by car. And by the beginning of 2024, the team plans to immerse the first tunnel segment. I just stand back and I bow low in awe at this civil engineering project. And there's little details too you'll learn about in the video. It's so cool when they float these segments out, Ben,
right?
And they put them together. There's a chamber between the two segments, and they extract the water out of the chambers, if I recall right, and it causes a vacuum, and that vacuum makes the two segments boop, kind of snap together. Isn't that something? It just wow.
Yeah, and really just thinking about these 78 or 79. 73,000 ton segments.
Oh, I'm sorry.
73,000 ton segments, and you're putting them together with enough precision, like you just said, to have a vacuum seal. That is, that's hard enough to do with two little pieces in your hand, let alone something that large. And very, very European, Ralph. Also, it's always good to mention public transit, always important. And the fact that this is designed for a train, not just cars like it would be here in the US, but for a train. Very, very cool. So, hey, and if this technology is good, I could definitely see it being used in more places. I've never been to the Pacific Northwest, but I could imagine like Seattle or something. They still use ferries to get from, one side of the sound to the other.
Absolutely.
Maybe something like that.
Well, it's interesting because about a month ago, we were, my wife and I went up to Vancouver Island, British Columbia, on the west coast of Canada, of course. And they extensively use ferry systems. Now, the distances there are much greater than 11.1 miles, as is the case with this project. But it's not inconceivable, maybe, that something like this could work. The other advantage they had, I'm sure, and I'm speculating, is that the seabed that you're talking about at this part of the Baltic Sea, I presume was flat enough, if you want to call it that, so that they could pull off this trenching business and then lowering these segments. So maybe not all environments would be conducive to this sort of thing, but I salute them for an incredibly clever, very clever scheme.
and very ambitious. That is above all, one of the most impressive things is just the ambition it would take, and then of course environmentally, when it's all said and done, it should be hey, as if nothing happened.
That's right.
Ideally.
That's right.
So there you go. So story number 1, perfect, and very incredible. Story number 2, not as impressive as digging holes and putting tunnels in, but let's talk about astronauts. That could be just as challenging. So everyone, story number 2.
Yeah, this one I couldn't resist. Maybe it's not as drum roll dramatic as the first story, but it's pretty darn interesting, I think. Anyway, so headline here is: future astronauts could use dust on Mars to 3D print tools and replacement parts. How could you resist that idea? I mean, it's just irresistible. So I picked this up first at Newsweek, and the image on the show notes shows the scientists working with this 3D printer, and then some of the results of their work. But let's explain here. Let's set the stage. In addition to oxygen, water, food, and buildings, of course, long-term occupation of Mars, and for that matter, the Moon, will require the fabrication of tools and replacement parts on site. Researchers at Washington State University, just up the way from where I live, recently demonstrated the potential for astronauts to 3D print tools on Mars made from the planet's dust. Now, it's a significant discovery, no surprise, because NASA can't transport everything they'll need from the Earth to Mars. And on top of that, to put this up further into perspective, just go to dollars and cents here, transporting materials to Mars would be hugely expensive and will be expensive, that which they can and will send over, like rovers and other things like that. For example, it costs, just to put this a little bit in perspective, costs $54,000 just to put 2 pounds of material into Earth's orbit. And so you can just imagine sending stuff all the way to Mars would be exponentially more expensive. So to help solve this...
Can't just run to Home Depot to grab something, a replacement screw or something like that. Yeah.
No, that's so true. So to tackle this problem, the Washington State University team of researchers discovered that small amounts of, and I want to stress this word, simulated crushed Martian rock. So they had to create a mixture from Earth materials, but that could closely simulate what Martian rock material would be like, and dust as well. So small amounts of simulated crushed Martian rock mixed with a titanium alloy, made a strong, high-performance material that could be used to 3D print tools and equipment parts on the red planet. And again, look at the image that we have in the show notes. You'll see some of the products they created. The researchers 3D printed tools using between 5 and 100% of the simulated Martian regolith, a black powdery substance intended to imitate the rocky inorganic soil and dust on the surface of Mars that could be collected by a robotic arm or rover. That's how you would harvest the materials and then use this process to ultimately 3D print. And they believe this Martian dust only or titanium and dust combinations could be used to build lightweight tools capable of carrying heavy loads and a host of equipment replacement parts as needed. It's very clever, very interesting, and a salute to those guys. And there, you're showing the close-up there of some of the parts and pieces they were able to create. Pretty interesting stuff.
Yeah, and obviously they're probably testing it out on different blueprints that you can download, from other places on the air, because I don't think you want a hip joint replacement made out of this regolith. Probably not the smoothest experience, but no, they've created a ton of different things, and everything from something very, very small to something very complex. So it's it's kind of what you're going to need, and I hope that they extend this, Ralph, as well to maybe trying to 3D print things, because I know that we've talked about it before, from moon dust as well. Being able to create, not just soil and fertilizer and stuff like that, but also actual parts that would be very, very important in space. So great line of research, and something that gets us one. Just solves one little piece of the puzzle of a permanent settlement either on the moon or on Mars. So very, very cool. Story number 2. Story number 3. Let's go ahead and jump ship a little bit and more jump planes to story number 3 with, something that you would think would be bigger by now, but, hasn't quite made it into the mainstream yet. But you can definitely tell that's where the industry is going. So story number 3.
Yes, this is a great example of the trends part of my job, looking for trend stories. Headline here: Air Canada orders 30 electric hybrid planes with a potential range of up to 500 miles. And I got this from interestingengineering.com, which is a wonderful outlet, by the way. And Ben, to talk, to kind of comment about this, we've talked about electric hybrid planes for a long time. We've talked about all electric planes off and on for a long time. But what I liked about this story is that this is putting some rubber to the road, so to speak, with a real deal, real world order of planes that are going to go into commercial use by a major carrier, in this case, Air Canada. And so that's why I thought this story would be interesting to get into. So the 30 hybrid electric aircraft that Air Canada just ordered are from an outfit in Sweden called Heart Aerospace, and capable of flying on battery power alone. And we'll explain more about this in a moment. The 30 passenger planes, designed for short distance routes, of course, will be propelled by 4 low noise electric propeller motors with a service ceiling of 20,000 feet. That's the distance from the surface of the Earth the plane can go. And at takeoff, when the Heart Aerospace aircraft is powered by batteries alone, it will have a range of about 124 miles. And you might be saying, wait a minute, that's so short. I mean, that's almost meaningless. Hang on. After the initial battery-powered range of 124 miles is reached, a reserve hybrid mode takes over. Much kind of sort of like a car's hybrid mode. The combination of fuel-based turbo generators and batteries delivers an additional 124 miles. So now you have 124 plus 124. And for additional climate friendliness, the turbo generators, look at their name, generators, what they're doing is they're going into action to feed the batteries to continue the electric motors, right? So for additional climate friendliness, the turbo generators can use sustainable green fuels. And that's the intent of the manufacturer as well. They're hoping that's going to be the case. And when using non-fossil fuel in reserve hybrid turbo generator mode, the plane can achieve up to 90% reduction in emissions as compared to a traditional fossil fuel-based turboprop plane of comparable size. And here's something interesting. If the plane is 30 passengers,
right,
but the manufacturer says if you just limit the passengers to 25, cut just 5 passengers out of the weight equation, the range can be doubled. That to me, it seems almost impossible, but nonetheless, they say it could be doubled to nearly 500 miles, according again to the Hart Aerospace team. The plane, by the way, is the ES-30, if you want to look that up and learn more about the plane in specific. And of course, the Hart Aerospace website, which I think, you're on there now, is wonderful, by the way, really good. And get this part I thought was fantastic, because so often you hear with electric cars and with certainly electric planes, you would think, well, that's all great. But if it takes 10 hours, 12 hours, 20 hours to recharge this puppy when it lands and gets to the gate, it's a non-starter. It's just not going to work well. According to the manufacturer, the plane's batteries can be charged, of course, a very powerful supercharging system, in just 30 minutes. So this makes it a very viable. I mean, it takes 30 minutes to deplane, get the passengers off, service the aircraft. You're probably looking at an hour. So well within that range, they claim you could start this whole equation over again and be in the air. So I just, again, to me, I like the story because it's rubber meets the road. It's really happening. It's going to go into service, albeit for short haul. But hey, every bit of this climate-friendly alternative, I think, is wonderful.
Yeah, and the fact that just 5 less passengers, which I'm not the best at math, but 5 less, double the range, can definitely go much, much further. But still, and one thing I'm kind of curious about is the fact that it's all electric, and they also say that the engines are much easier to care for because they don't have to use jet fuel and stuff like that. Ralph, for anyone who's driven in like a Tesla, let's say, or any kind of electric car, one of the really cool things about electric vehicles is they're all torque. You stomp on the gas pedal, so to speak, and they just take off. That's why the Tesla can go from 0 to 60 in like 2 seconds or 3 seconds, whatever it is.
Absolutely.
Ralph, I'm curious if maybe electric airplanes have, a little bit of a similar benefit, and maybe runways could be even shorter, thereby putting airports in different places.
Oh my gosh. Wow, Ben, that's genius. Yeah, I hadn't thought about that, but I think you're, from a mechanical engineering point of view, very much right on target, because that is a great thought, because you would think it would expend would suck up a lot of battery energy to super torque. I have a RAV4 Prime, and my RAV4 Prime gives me about 45 miles of pure EV before it goes into a traditional Prius like hybrid mode. Okay, but with that said, you're right. I mean, you put the pedal to the metal and it's just seamless, effortless, boom.
Yeah.
So if you could do that for takeoff, you could have shorter runways. Now, landing, that could be interesting.
No.
Again,
landing, you put that brick wall up, and landing can be very, very abrupt. It's perfect. But no, and I'm just curious about,
that's a fun idea.
Maybe putting smaller runways, more airports in different places that you wouldn't traditionally have, Ralph. And that's always the fun thing about our segments, is that you start with an idea, and the actual benefits and the actual changes to let's say the plane ecosystem. Those can come later because you can do things that you couldn't do before. So great story. And it looks very, very cool as well. Looks kind of classical, but at the same time, still very, very modern. So, fun looking plane as well. That was story number 3, everyone. Story number 4, our last one, and then we'll have our bonus story here in just a second, which will be very quick. But story number 4 is also, going to be a lot of fun because, tiny, mini, create solar powered robots. So Ralph, I'll let you go ahead and introduce it. But story number 4.
Yeah, story number 4. And it reminds me that miniature tiny, sometimes microscopic, but certainly tiny miniature robotics. Then if you think about the last year of us being together, that's been a theme that's popped up over and over and over again, along with artificial intelligence, along with genetics, along with other things that we just keep seeing bubbling up to the surface over and over again. And this story fits really well into the ultra tiny or very small robotics world. So scientists create solar powered robots smaller than an ant's head that can move and think on their own. Got this from ScienceDaily.com, which is really a great website as well. So here we go. Cornell University researchers have installed electronic brains on solar-powered robots that are 100 to 250 micrometers in size, smaller than an ant's head, so they can walk autonomously without being externally controlled. And this is the really important part of this. To date, making ultra tiny robots that can crawl or swim, walk, or even fold themselves has been done, as you know, Ben, we've talked about this many times before. A lot of them have been manipulated using magnetics or wires to provide an electrical current to generate motion. And this was interesting in the article, or even laser beams focused directly onto specific locations on the robots to get them to move and do what you want them to do. That was new to me. I thought that was interesting. But Cornell's tiny solar-powered experimental robot is wireless and has a programmable brain chip to direct its movements for itself. So that's the big aha. The brain, by the way, in the new robotics, little tiny robots, is a complementary metal oxide semiconductor, aka CMOS clock circuit that contains 1,000 transistors, which is laughably tiny compared to, say, the brain chip in your computer, but nonetheless, it's still cool. Plus an array of diodes, resistors, and capacitors. And the innovation, to kind of summarize it, and friends, please go to the article, use the link in the show notes because there's so much more information. But this innovation sets the stage for a new generation of tiny robotic devices that can potentially, because they can move on their own, they can be programmed and so forth, they can potentially do things like track bacteria, sniff out chemicals, destroy pollutants, conduct microsurgery perhaps. And I love this last one, even scrub plaque out of arteries. So the possibilities are amazing when you have something as smaller than an ant's head and can move on its own and is solar powered. Now the solar powered part's interesting because do you expose it to some sunlight for X amount of hours or minutes or whatever the case may be, and then deploy it into the body to do something like scrub the plaque out of arteries? And once it's pooped out, its energy is gone. Is it just pass out of the body? There were a lot of questions I had remaining after looking at this, but nonetheless, like you point this out so often, just put this technology out there and people are going to find all kinds of interesting ways to use it. So I just love this story. I thought it was really cool.
Sometimes this research does lead to, tools without a job. But hey, once you create the tool, you can find the job later. And, for these little things, my immediate response is, and I don't know how they would survive in the open atmosphere, but imagine, Ralph, if you could sprinkle these on like a farm or some kind of place that you want to track the soil. And, if something happens, if it detects a certain kind of fungus, if it detects a certain kind of bacteria, it would move its way to the surface. And then, the farmer would, kind of get, some kind of device to scan the little microchips. And then that would let them know constantly if there's immediately a problem with the soil, something like that. I'm sure that all of this would be possible at some point. So very, very cool. And the fact that it's so tiny, tons of different applications. So like that a lot. Ralph, that was story number 4. Story number 5, and I'll include this in the link myself, and we'll probably cover this when you get back here in a couple of weeks. But I just want to quickly go over this one because I saw this one did reach a lot of people in the mainstream as well. And Ralph,
it's so funny. I just saw that this morning. Keep going. Yeah, this is great.
Yeah, sure. And let's see real quick. Chat. Here we go. Okay. MIT engineers, and MIT we always always cover their stuff. Their department always covers a lot of really cool stuff. MIT engineers build a battery-free wireless underwater camera. So this is a camera that uses, I believe it was sound waves that travel through the ocean to charge a tiny battery, and you can see it there on the screen. I mean, it almost looks like a bulkhead for like a submarine or a ship or something like that.
Yeah.
And then inside of it, there's there's a little chip, there's a little sensor, there's a camera, and all of this can take pictures for up to several weeks floating in the ocean with no battery whatsoever. It's totally powered by sound waves that hit it, convert it to electromagnetic energy, and they're able to take pictures for much, much longer. So, Ralph, you can imagine a device like this being used to put cameras in places for durations that you never could before. And of course, then you would have to go retrieve the devices to get the images, but still being able to go out there with no battery and just float around and take pictures, that could mean a lot more eyes in a lot more places. So for conservation efforts, for kind of identifying species and taking good head counts, all of it just good stuff.
Hey, Ben, I probably haven't had a chance to read the whole article, neither have I.
Sure.
But you talk about sound waves being the way that induces the energy to then create the electricity to allow this thing to do its job. Mm-hmm. Are they just, do they have to provide those sound waves, or is it just, say, natural sound waves in the environment where the device is?
Yeah, they said that those sound waves can come from any source, like a passing ship or even marine life. The camera stores harvested energy until it is built up enough to power the electronics that take photos and communicate data. So it can come from anywhere. It can come from, even just crashing waves of itself. And for anyone who's gone swimming, stuck their head underwater and listened, sound travels a good distance.
That's true.
And whereas I think it's solar? I think it's solar. Like as soon as you get just a couple of feet underwater, solar vastly loses its ability to transfer energy. So sound is a much more effective way to power these things than photovoltaic, because these things need to go underwater.
That's still so cool.
All around, it's a very cool idea because lack of a battery, they're hard enough to recycle, and you definitely don't want to put hundreds of batteries into the ocean that could potentially leak, cause harm, and pollute itself. This is just a great way to do that itself. Yeah. So, Ralph, maybe when you get back, we'll cover this in more detail, but that was a really cool story that I wanted everyone to know as well. But everyone, stories 1 through 4 as well as 5 will be in the show notes over at computeramerica.com. And until next time, I want to thank you so much for coming on. And everyone, I'm sorry, I was about to say the first Friday of every month like it used to be. Every single Friday, except for the next 2, Ralph will be here. And Ralph, I hope that you have a great vacation, you enjoy yourself, and you come back, ready for more tech news. And hey, maybe in 2 weeks' time, we'll have solved all the problems. Everything will be fixed. We have cured everything. It'll be great. We'll find out when you get back, Ralph. Until next time, everyone have a great weekend. Have a great time. Bye, everyone.